So today we will discuss about a topic called process management. In this topic, we will see what actually a process is and what are the different terms which are associated with the process. And let's see how this operating system manages the process. Okay, let's start with the definition of process. You can see here a process is a unit of work in a system. A system consists of collection of processes, some of which are operating system processes and some of which are user processes. So basically a unit of work or a unit of task is called as a process. Understand? So you can see here there are two types of works uh, which uh, which goes on in computer continuously. One is the works which are associated with the system and the works of a user. So these two can also be called as a process. We can call them as a system process and the user process. So basically a, a process is nothing but the work which is happening right now. So you know that there are different types of programs um, which are there in your system in executable form. You have movies, you have songs, you have word documents, you have different types of programs. So we call that each program as a process when they are in executable form. Understand? So let's see some of the uh, terms or some more details of the process, um, of how a process executes and how a process manages all the things. Okay, so right now I will try to explain you some scenario so that you can understand and you can relate to the process more clearly. Suppose if you are watching a movie and that movie right now is in hard disk, so it is called as a executable program. The movie in your hard disk is called as a executable program, and when you double click on that program or on that movie, what happens is you are executing that program. So that executable file is placed in the main memory. It is stored in the main memory. Okay, when that program is stored in the main memory, then that program is called as a process. Okay, so when it is in hard disk, we call it as a program, and when we store or when we simply transfer that program into a main memory, that is RAM, we call that as a process. Understood? So process is an active thing, whereas program is a passive thing. So we can define a process as a program which is currently in execution is called as a process. Understand? Or we can call it as a job also. But for this class we will stick to the term process. So process is nothing but the active program which is currently executing. Understand? And these are some of the terms which are associated with the process, like text section, stack, program counter, data section, and heap memory. So these are all the components, you can say, as a components of a process which which describes about a process. The text section is nothing but program code. The code of that program is called as a text section, and the stack is somewhat like a storage area where it stores data temporarily, like local variables and some addresses and all those things are stored in stack. And program counter is the address of the next instruction to be executed. So process is nothing but it's a collection of instructions to be executed. So program counter holds the address of the next instruction to be executed. And data section is nothing but the where that the original data exists, the global variables, and the original data where the data where the content exists. And heap memory is the memory which is allocated to the process dynamically. So we will talk about these all these things the in coming classes. So basically these are the terms which are associated with a process. So when a process is created, automatically these are the attributes of a process. You can see this is how a process looks like. Okay, it has a stack, it has a heap, it has a data section, it has a text section, all those sections like this. Understand? So whenever a process is created, automatically these things are created, or these things will be associated with a process. So I hope you understood what is a process. Okay, you can call a movie as a process, you can call a song as a process, a C program or C plus Java program or anything which is currently running in the computer, it is called as a process. Got it? And these are the terms which are associated with the process. All right, so let's try to see some more points which related to the process. The first point here is although two processes may be associated with the same program, they are nevertheless considered two separate execution sequences. Okay, so this is an important point which we should understand about the process. Okay, so a program is nothing but a combination of processes. So a movie can be divided into, or a movie can be made up of number of processes. Understand? So suppose if you're browsing something, if you opened a browser, so when you click on a browser, that means the you are converting that browser into a process. And what you will do is you open another browser. Okay, so now you have executed two programs that is of same type, browser type. Okay, so even though even though these processes belongs to the same program like browser, okay, but actually they execute differently, or they execute separately. Okay, so a program may have n number of processors, and that processors will execute independently. Okay, so one processor is they may belong to one single program, but the execution of that process will be done independently. So that is what the statement here is. So although two processes may be associated with a single program or a same program, they nevertheless consider two separate execution sequences. So even though they belong to single program, they are executed, so they are treated separately and they are executed separately. So that is what the statement means. So you can see your example. Here you can see a same user may invoke many copies of web browser program. So our program is same type of program, but he's invoking many copies of that one. So that means you are invoking different number of tabs in a single program. Generally we do that, right? When we open a browser and we create a number of tabs for that browser, that means we are working on the same program, but we are creating more than one process for that same program. So each of these separate process, and although the text sections are equivalent, the data heap and the stack sections vary. So when you create a different processors for a same program, the text section, that means the program code of the program will be same, but the data section, the heap section, the stack sections will be different. Okay, so basically the source code of the program will be same, but the heap memory allocated to it, the data section of it, and the stack which is associated with will be different. Only the program, the code will be same, and the remaining things will be different. Got it? So this is one point. And the second point is, as I said, a program is a passive entity. That means executable file is a passive one. That means we cannot call it as a process. So when that program is in execution, that means when that program is transferred to our main memory, then we call that program as a process. So this thing I have already covered. Okay, so you should know the difference between a program and a process. Program is a passive thing. That means it when it is in the hard disk, and when it is in the RAM, it is called as a process. A program becomes a process when an executable file is loaded into a memory. Okay, right, right. So a process can also have a state. So let's discuss this. A process can also have a state. Excuse me. Okay, now let's see what is process state. So we have seen what are the different terms which are associated with the process, and we will see this also, process state. Process state is nothing but the different uh, phases a process undergoes from the starting of the process to the termination of the process. So you have different states a process undergoes. Let's see what are they. As a process executes, it changes state. The state of a process is defined in part by current activity of that process. Okay, let's see what are the different phases a process undergoes. The first one is the new state. New state is the state where a process is created. So the process is being created, we call that as a new state. And when the process or the instructions are being executed, we call it as a running state. That means the process is currently in running state. Okay, and we call a process is in waiting state when it waits for an event to occur. Okay, such as IO completion or reception of a signal. Suppose if we are working in a Word document, and we are so that is the process. Word document is a process, and what we have done is we have given a print instruction or print instruction to the computer. That means we have invoked the output signal. So now the process, Word document process, will be in waiting state for a fraction of a second, because it is waiting for the printer to be activated. So that this is called as a waiting state. So or if some interrupt occurs, then the process will wait for that interrupt to be resolved. The second one is ready state. So after the waiting state, after the process completes its IO operation or any other operation, now it is ready for the execution. So the if the process waits for the processor to be assigned, then that state is called as a ready state. That means the process has completed some task and it is ready to reallocate it. Okay, it is ready to perform the task, or it is waiting for the processor to be assigned. So that is called as a ready state. Okay, so it is ready to do the work. And the last state is the terminator state. So when the processor finishes its execution, and when it completes the task, then it is called as a terminated state. So here the total the components which are associated with the process will be terminated, like heap memory, like stack, and the text section, data section, all are also terminated. So in this the diagram you can see the different states of a process. This is where the process is created new, and after the process is created, it will wait for the processor to get assigned, and it is ready to get process. So this is the ready state. Now when the processor is assigned to this process, it will be in the running state. That means that a processor is right now with this process, it is in running state. So after the process completes its execution, then it will go to the terminated state. So in between the new state and the terminated state, there are other states, that is waiting state. So when the waiting state will generally occur when that process completes, or it undergoes a IO operation, then IO event, then the process will be in waiting state. That means if the printer is busy, it will wait for the printer, and when the printer is allocated, it will instruct the printer to print a copy. Okay, so after that is done, then it is again ready for the processor. So the processor will again fetch this one, and it will run the program, and after successfully running the program, the process will be terminated. So these are the different states of the process: new, running, waiting, ready, and terminated. Now this is the important point, or the thing about this process. A process in operating system is represented in the form of a PCB, or process control block. When a process is created, it is created in the form of a process control block. Nothing but a block, um, which contains all the information about a process. Okay, so this is the diagram which you are seeing is an example or a block diagram of how a PCB looks like. So this is a PCB, process control block, which contains all the information about the block. So in that you have a process state. So by this you can see, you can know where in which state the process is. It has the process number. If you assign a number to a process, it will hold that number. Program counter, registers, memories, list of files which are associated with all the information is there in the PCB. So it's like a box which contains all the information which are related to a process. So let's see individual things here in a PCB. So it's have a process control block has a process state which uh, which tells uh, in which state a process is right now. So if it is in which state, it may be in ready state, it may be in waiting state, it may be in running state, or it may be terminated. So the process state, this will um, explain us, or this will tell us in which state a process is currently. And program counter, I already told you, program counter will hold the address of the next instruction to be executed. So you should understand this hierarchy. A program is made up of number of processes. A is made up of number of instructions. So there may be more than one instructions in a process. So this program counter will hold the addresses of the instructions in a process. So it holds the next address to next instruction to be executed. And CPU registers will are the memory devices which holds the state or the information of the process. Suppose um, you can read this. The state information must be saved when an interrupt occurs to allow the process to be continued correctly afterwards. Okay, suppose a process is running right now and some interrupt has occurred. So when the interrupt occurs, the process saves the current information in CPU registers. Information like the the state, the state in which it is currently, and the program counter value, and the memory addresses, the information which is holding. So all the current information is stored in the CPU registers. And when the interrupt completes or when the interrupt is over, then it will continue from where it has left. So in order to remember the current state or the current position, it it saves that current information in a CPU register, so that after a interrupt completes, it will start from that point. So that is the use of CPU registers. And the CPU scheduling information, so this holds the information about the priority of the process. So look, in computer there are thousands of processors running, okay, the hundreds and thousands of processor running for a second, per second, okay. So each and every process has its number and its priority. So this priority means when a process should run, or when what is the importance of the process. Is it important? It can be, or it can be simply avoided or ignored. So all the information about the process will be there. So process mainly relating to its priority. So based on the priority of a process, it is scheduled. That means the work is allocated to that process, or the CPU is allocated to that process. So this CPU scheduling information, which it will hold the priority of a process. That means how important is this process. Okay, if it is high priority, then it will give more importance, and it will allocate the CPU to this process first. If it has low importance, then it will, the CPU will be allocated after some time, or after all the processes are done, the CPU is allocated. So the CPU scheduling information will hold the information about how and when the CPU the process is scheduled. That means when the CPU is allocated to the process. And memory management information, basically this holds all the information which is related to the memory, or the memory which the process holds, like heap memory, the registers memory, the memory from where the original program has existed. So all the information related to the memory is stored in this memory management information uh, space. Okay, right. So these are all there in the PCB, process control block. You can see all these things in PCB. And accounting information, so this information includes the amount of CPU and the real time used, time limits, account numbers, jobs or process numbers, and so on. So this section here will hold the information about um, how how much time is a particular process has been executed, or how much the CPU is allocate, how much amount of CPU's time is allocated to a process. So all the, and how many what we say, account numbers it has handled, how many jobs it has processed. So all the information regarding this is stored in accounting information. So basically, the time which is related to the CPU and the process is stored here. And IO status information. This information includes the list of IO devices allocated to the process. See, the process may use different resources in this, like RAM, CPU, like other resources like scanner, printer, or anything, monitor, even monitor. So this IO status information will hold the information of all the resources which the processes have accessed. Okay, and you can see here, this diagram shows us the shifting or switching of the control from one process to another process. See here, process P0, this is one process, and P1 is another process, and in between we have the system calls or interrupts, or the the time where the operating system takes care. So here currently the P naught is executing, and after some time the control is shifted to the system call. That means an interrupt has occurred. So when that interrupt is occurred, then what will it will do is it will save all the information to its PCB. So save state into PCB 0. So the PCB 0 belongs to process P naught. So it will store all the information to the PCB 0 because an interrupt has occurred. So in this time, the interrupt is right now from here to here. The interrupt will take control of the CPU. So in during this phase, the P naught will be in idle state, and P1 is also will be in idle state. You can see here from here to here. And after that interrupt is finished, after interrupt is finished, then the control will go to process P1. That means reload state from PCB1. So the now the control is being shifted to process P1, PCB1, process control block, which belongs to process P1. Now process P1 is executing. So when the process P1 is executing, at that time process P0 is still in idle state. Remember one thing, at a particular point of time, CPU will execute one instruction at a time. So it will not execute both instructions at the same time. So when the P1 is in execution state, P0 will be in idle state. Okay. Now from here to here, P1 holds the control, and after executing completes, it will again it will first saves the information in PCB1, and again it will give back the process to the interrupt or the system call. And after the interrupt has finished, the control again is given back to the PC naught or a P naught. So in this way, the control will switch from one process to another process. So here we are only looking in just considering only two processes, P naught and P1. But in general, there are thousands of processes which are running, and the switching of this control will be so fast that we will not realize that the program is in idle state or the program is currently executing. So we don't realize, because the execution power and the execution speed of the computer system is that much fast. Okay, we think that all the programs are running at a time, but at the background the switching is happening. That means while one process is running, the other process is in idle state. While the interrupt is occurred, all the user process are in idle state. Okay, but we don't recognize that, we don't realize that one, because of the speed of the computer. Okay, so this is how the process continues. So that is it. So this is all about a process, the information which is related to the process. I hope you understood. If you have any doubts, you can ask me now.